Okay. Um, so today we're working on geometric series. We're actually adding up ones that are from a geometric formula rather than the arithmetic formula. So you get each term by multiplying by something, multiplying by that r. This one will have plus minus plus minus. Often, if the r is negative, it'll change sign every other term rather than being all plus or all minus. Not a big deal. Geometric geometric sequence formula review. We've used that one before. Okay, we're using R. We will use this again today to find certain values, to be able to write it in other notations. Geometric summation notation. So same idea as the arithmetic one. What we're going to do is we're going to use this either to come up with our formulas, to come up with our totals, or we're going to write it like this, in which case we're going to have to write the formula. And then geometric series formula. So this is the sum, how to find the total. Much more complicated formula on this one. Much more complicated formula. You have to be careful how you type it in. You've got to be careful how you work it on this one. It's a sub 1, the first term, times 1 minus r to the nth power, not n minus 1. The other two are n minus 1. This is to the nth power. Okay, so notice the difference between the previous geometric formulas and this one where it's n instead of n minus 1, all divided by 1 minus r. It's a complicated formula, much more complicated than the one we're using for arithmetic sequences. Much more complicated formula. You will have to be extremely careful how you put this into your calculator. Okay, you're going to have to be extremely careful about how you do that. Okay? You'll have the formulas there for the test. You have them in front of you. You just got to be careful how you use them more than anything else. Okay, this is much more calculator heavy than the other ones we've done, but still, you have to be able to type it in correctly. Okay. Questions? All right. So this first one is actually a review. Which ones of these are arithmetic? Which ones are geometric? Find D or R accordingly. So this is a review. We've been doing this. Take a minute to go over and take care of this. Okay, shouldn't take that long. You have to be able to recognize the patterns. You have to be able to recognize what's going on. It's not just always figuring it out, just being able to look and say, okay, what do I have? This one is a linear style equation. If I have something times n, this one would be arithmetic, and D would be 2. I have something raised to the nth power. The n is in my exponent. That would make it geometric. And R is what I'm raising to that power. So on the next one, this would be geometric. And my R would be -7. This one here would be geometric. And R would be 3. Yeah, because what am I raising to the nth power? -7.
But then don't you multiply that by 1/3?
No. It's only the part that I'm raising to the power. Because if you go and you look at the formulas, what our formulas have? Our formulas have a sub 1 times r to the n minus 1. Now, sometimes this can be simplified. So for like example, this is a and r are both 4. The first term and r are both 4 in this one. That's why it's not n minus 1 power. This one kind of works the same way. It doesn't have to be n minus 1 on the power. It's just that power. Whatever I'm multiplying, because I'm not going to increase by 1/3 each time. 1/3 is my starting point. What am I going to do? I'm going to go up by -7. I'm going to multiply times -7 each time.
So your A1 is 1 and 1/3?
And that one would be 1. That one actually -7/3. And we'll kind of talk about that a little bit later on. It can be confusing what the first term is when it's in summation notation. We'll talk about that, how to make sure you get the first term correct with the problems we're actually doing later today. Okay? Because like I said, it can get confusing. I still have to stop and figure it out sometimes. Okay? This one would be arithmetic. and D would be 1/6, and this one would be geometric, and R would be 5. R is what we're raising to a power, whether that's the nth power or n minus 1 power or n plus 2, n plus 1 power. Doesn't matter. If n is in the exponent, the base of that exponential, the base of that power is what R is. The easiest way to figure out what the first number is, plug in 1 for n and see what you get. And that's what we will actually be doing later. Okay. Okay, today's kind of, there's 2 parts to today. I've got a lot of example problems to do. We're really only doing 2 basic things today. We're finding the total, and we're writing it in summation notation. Okay? Finding the total will be difficult. There's a lot of example problems to go with these. First one, find the sum. Okay. So, take negative 15 plus 30, subtract 60. There's only 6 numbers there, right? Those you can just do on your calculator. Wouldn't take that long to actually add that first one together on your calculator without using the formula. Okay? And if you do that, you end up, and I did this earlier just to make sure I was doing it right, 315. And if I gave you a test question that looked like that, dear Lord, please, it's only 6 numbers. It's not like it's 20 numbers or 30 numbers that I'm asking you to add up. It's 6 numbers. Add them up by hand. You got a calculator that will do the additions and stuff for you. Do it by hand. Now, that being said, I know exactly what the answer is. This is the easy way to do it for this particular problem. I am also going to do this same problem using the summation formula. Okay? And this is our summation formula. Okay. Now, most of the problems that we do, I give you everything you need in the formula. You just have to plug it into the formula and do it correctly. This is the only one where I don't give you everything you need right off the bat. However, it's very easy to figure out what we don't have. We don't have n. We don't have r, but r is extremely easy to find. Yeah, I need the first term, I need r in 2 places, and I need n. So my first term, that's obvious, it's negative 15. R, what I multiply by would be, how do I get from negative 15 to positive 30? Positive 30 to negative 60, I multiply by negative 2. And then n, that's 6. We got 6 terms. I can count them. 1, 2, 3, 4, 5, 6. Okay? That's easy to do. Let's plug them in the formula. Do it on your calculator. Make sure we get the same answer we just got. So we can do it 2 different ways to make sure, and this is really what I just got done doing before class, because this is one of the ones where the formula is easy to mess up. To make sure I got it right, you take something you know how to do the easy way and do it the hard way, make sure you get the same answer. Not a bad idea. So the sum of the first 6 numbers is the first number, negative 15, times 1 minus r, which is negative 2, to the nth power, which is 6, all divided by 1 minus r, which is negative 2. Okay. Now, how to do this on your calculator? There's a couple of ways. I'm going to tell you exactly what I do when I do it on mine. I don't do this in one shot like I do a bunch of the other ones. I do it part by part. My first part is I do this right here. I do all of this right here in one shot. Everything inside there. So I take 1 minus parentheses negative 2 end parentheses to the 6th power, exactly as it's written there. Okay, so I do 1 minus parentheses negative 2 end parentheses to the 6th power, and you get negative 63. That's just that part inside. Okay. Now I multiply that times the negative 15 that's in front, times negative 15, and you get 945. And then I take 945, which is what this entire numerator has become, and divide it by my denominator. And you can figure this out in your head. You don't need your calculator to go, ooh, 1 minus negative 2, that's what? That's 3. So I divide by 3, and look what I get. I get 315. I get the exact same number I did by adding it up the easy way. Okay? I get the same number, 315. And I hear some of you saying, well, Mr. Ors, why did you do it the hard way when we already did it the easy way? To make sure you know how to do it. Okay? I tell when you're doing something complicated on your calculator, and it is complicated on your calculator, I always say, do something you know that you can find out without your calculator, and do it with your calculator, make sure you get the same answer. When my calculus students are learning how to do extremely complicated things on their calculator, I say, do an easy one that you can do by hand, know the exact answer to. Do that one on your calculator and see if you're getting the right answer. If you're not getting the right answer, you're not punching it in correctly. So do something you know the answer to make sure you know how to do it. Okay? Know how to use your tool correctly. And with calculators, it's easy. Do something you know the answer to on your calculator to make sure you're doing it right. Make sure you're punching it in correctly. Okay? Now the next one. Okay, I have the three things I need. I need the first term, I need R, I need N. Okay. My N is 5, my first term is 12, my R is 3. So the sum of the first 5 terms is 12 times 1 minus 3 to the 5th power divided by 1 minus 3. And like I said, I do it in parts. I do the part inside the parentheses first. 1 minus 3 to the 5th. I get negative 242 times 12, negative 2904, divided by 1 minus 3 is negative 2, and I get 1452. Okay? That's it. This is extreme. You're not going to do this one by hand. You don't want to do it by hand. I don't want to do it by hand. It's extremely complicated. Do the next one here. So I know what N is. N is 6. I know the first term. I know what R. So the sum of the first 6 terms is 2/3 times 1 minus 1/3 to the 6th power all over 1 minus 1/3. Now, I'll look at this one, okay, and it doesn't always work out this way. But realistically, what's my denominator? What is 1 minus 1/3? It's 2/3, right? I have 2/3 of my numerator and 2/3 of my denominator. What are they going to do to each other? Cancel each other out. So what's my answer going to be? My answer is going to be what I get here from the parentheses. I don't need to worry about the rest of the formula in this one, and that's because we're smart people and we realize, ooh, this is 2/3, and the 2/3 and 2/3 cancel each other, so I only have to do what's inside here on this one. Once again, put parentheses around your fraction before you take the power, and use the fraction button. Okay. So 1 minus, parentheses, 1 fraction 3, in parentheses to the 6th power, and you get 728 over 729. Almost won. Almost, but not one. Yes. Is it coming up as a decimal on yours?
Yeah.
This is one where it's one of those ones. I'd rather not. I'd rather have the fractions, but making sure that yours comes up as fractions is much harder. The arithmetic ones, no, you can work out the fractions and figure out the fractions for that one. It's generally not as big a deal. This one, on the other hand, it gets really nasty in a hurry. I'm not surprised your calculators aren't necessarily doing this correctly. It should still do it as a fraction. It's not that nasty a fraction. What is it giving you? 0.9? Yeah, 0.99. So they go out several places. Okay, try to do it without doing that. Okay. So let me see if I can do this. Times 2/3 divided by 2/3. Nope, mine works as a fraction for both parts. And I understand your calculators aren't. I don't expect you to go out and spend $50 on the calculator for this class. It'd be nice to spend $10 to have your own rather than use one of mine, just because it'd be nice to have one handy for you. But by the same token, I don't expect that. This is one that on the test, I do have the decimal answers as well as the fraction answers. Okay. I will put mine up in what I get, which means I'll put fractions. If you got a decimal and you want to check to see if it matches, how do you do that? Take 728, divide it by 729. Not as a fraction, do 728 divided by 729. It will give you, if it gives you the same decimal number you just got, then it matches. And that's what I do on the test, is I do this and I get this answer. I will have the decimal equivalent to that because I know that on these problems in particular, sometimes getting the fractions to work out on these calculators doesn't always happen. So I will do that. Okay. I do try to have them so they don't come up too nasty for you guys on the test, but sometimes that happens anyway. It's life. So this one, I need the sum of the first 10. It's 5/6 times 1 minus -1/2 to the 10th power divided by 1 minus -1/2. This one gets kind of, yeah. Let's see. Do the part on the inside first. 1 minus parentheses -1/2 in parentheses to the 10th power. Ooh, 1023 over 1024 times 5/6, still a fraction. And then divided by, and then I'm going to do parentheses, 1 minus -1/2 in parentheses. And I get 1705 over 3072.
Would that be 0.555?
I'll check in a minute. 1705 divided by 3072. And I get 0.5555. 0130208. Yeah, and like I said, I'm not surprised with these ones you're getting decimals. I'm not. With the arithmetic ones, it was a little easier to make sure that you got them as fractions only. With these ones here, I understand your calculator's not being strong enough to hold the fractions very well. Okay. And that's what it does. It says, whoa, I can't do fractions. I'm going to do decimals because I'm lazy. Well, mine's not quite as lazy as yours. Okay. Questions on these first 4 examples? Okay, so same idea. Like I said, I want to make sure that you understand how to do them because, like I said, these are complicated formulas. These ones are going to get nasty in a hurry too. Problem is on these, I'm not given R. I know what N is. N is 7. A sub 1 is 3, but I need to find R. R, remember, it's geometric. I know that. R is easy to find. Pick a number in the sequence. In this case, 4.1. And divide it by the number in front of it. Sorry, 4.5. And divide it by the number in front of it. 4.5 divided by 3 gives me 1.5. So that's what my R is. And this answer will be in decimals because that's what you have. You've got decimals. Okay. So, I'm not given R, I have to find R. It's not that bad. So, the sum of my first 7 terms is 3 times 1 minus 1.5 to the 7th power divided by 1 minus 1.5. It's the same formula. Same one I've been using. You have to find it's a little more. It's not that the formula is more complicated. It's that you don't have all the numbers given to you right off the bat. Does that make sense? You have to deduce what one of the parts is. So 1 minus 1.5 to the 7th power. Negative 16.0850, blah, 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 times 3. You divided by negative 0.5, because 1 minus 1.5 is negative 0.5. And you get 96.5152625 to be exact. 3 decimal places at least 3 decimal places.
That's what you got in the very end.
That's what I got on the very end of mine. Yeah, at the very end. That's the final answer. Yes, that's my final answer.
Okay.
And I did not need to phone a friend. Okay, so this one, I know what N is. I know what the first term is. I need to find R. R is 300 divided by 400, or 3/4. I would like to try it as a fraction and see what we get. Just go from there. Decimal I wouldn't necessarily get too worked up over. So the sum of the first 6 terms is 400 times 1 minus 3/4 to the 6th power over 1 minus 3/4. 1 minus 3/4 to the 6th power. Ooh, I get an ugly fraction. Times 400. Oh, and I made it a decimal. Then I multiplied it times 400. Divided by 1/4. Still a decimal. Mine made this one a decimal. Mine said screw it. So mine said, no, I'm not going there. So I end up getting 1,315.234, and then 375 after that.
Fractions like 84,175 over 64.
Huh?
The fraction's 84,175.
It got you the fraction?
Yeah.
Cool.
It's not cool.
No, mine freaked out on it. Mine said, no, I'm not going there. Once I multiplied times 400, it said, no, we're done. So if mine says we're done, then decimals are fine. Okay, last 2 examples, and then you get to do some on your own. So this one is a little more complicated, but it's not too bad. I have to figure out each of the parts. Remember, I have 3. I have N, I have R, I have a sub 1. N, that's easy because I'm starting at 1 and going to 4. And on the ones for the geometric, you will start at 1 and go to 4. Or go to whatever. So N equals 4. R, I have 2 to the nth power. So 2 is what is the base of my exponent. So that's what my R is. My R is 2. The problem is, what is my first term?
4.
Nope, my first term is not 4. My first term is 2. And here's what you want to do every time with these. Every single time when you have one that's in summation notation, what you want to do to find the first term is plug in 1 into the formula. What do you get? That way you don't have to worry about the exponent being some goofy thing or not following this pattern, because if you look, 2 to the nth does not look like what I have here. This one has n minus 1 as the power. That's got n as my power. What they did is you just simplified things down to give you that one. It's still a geometric pattern. So what do? I go, okay, 2 to the first, which is 2. And that's what you want to do. You want to plug it in and set it up. Plug in 1, see what you get. Do that. That's your first term. And then go from there and plug it in the formula. So the sum of the first 4 is the first term 2 times 1 minus 2 to the 4th divided by 1 minus 2. And you end up getting on this one 30. That's what I was kind of thinking. It's not that big because they're only doing the first 4 numbers. 2 plus 4 plus 8 plus 16 gives you 30. Yeah, and this one actually, you could generate their first 4 terms and add them together. It wouldn't be that big a deal. It's not nasty. Some of these other ones, generating terms, that gets nasty. So this one, same idea. Our n is 6 because we're going from 1 to 6. Our r in this case is 3 because that's the number we're raising to the power. That's the base of our exponential is 3. And then to find the first term, a sub 1 is 2 times 3 to the 1 minus 1 power. Plug in 1 for n. What's 1 minus 1? 0. What's 3 to the 0? 0. No, 3 to the 0 is not 0. 3 to the 0 is 1. 2 times 1 is 2. No, so the 0 power is not 0. It's 1. It would suck if your first number was 0, because then you'd have 0 times the whole thing, and you wouldn't have a total now, would you? Okay, so you put it in the formula. S sub n is equal to 2 times 1 minus 3 to the 6th power divided by 1 minus 3. Minus 3 to the 6th power. And you'll end up getting 728. Okay. Question. Hardest part about these problems? Using this correctly. And that honestly, that's it. The hardest part about these problems is using this thing correctly. Making sure you type in the numbers and everything properly. Okay? Your turn. Work on these examples. So I believe there's these 4 and then these 4. Go ahead and work on them for a while. After a little bit, I'll do these 4, and then give you time to finish up the rest of them if you haven't done that before I do the next 4. Okay, so I'm going to go ahead and do these ones here, and then I'll go and give you guys a few more minutes to finish the other ones up, but let's go ahead and do these ones now. So we know what n is, it's 5. We know what the first term is, it's negative 20. R in this case is negative 1/4. Okay. So the sum of the first 5 terms is negative 20 times 1 minus negative 1/4 to the 5th power, all over 1 minus negative 1/4. So 1 minus parentheses negative 1/4 in parentheses to the 5th power. Ooh, gave me a syntax error too. What did I? Oh, that's what I did. Delete. Power. There we go. Times negative 20 divided by 5/4. And I end up with, this one did give me as a fraction, negative 1,025 over 64. That's what I got on that one. This one, I have the first term. I have n. I have r. It's just plugging it in. S sub 8 is 16 times 1 minus 2 to the 8th power, all divided by 1 minus 2. So 1 minus 2 to the 8th times 16. And I get 4080. That's what I get for that one. This one here, the sum of the first 7 terms is 18 times 1 minus 1/2 to the 7th power, all over 1 minus 1/2. So 1 minus parentheses 1 to the 7th power times 18 divided by 1/2. And I get 1,043 over 32. Sorry, 11,043 over 32. And once again, if your calculator is spitting out decimals, just take my answer, make it a decimal. This one looks like it's going to be huge because a sub 1 is already a big number on the next one, but r is negative, so it changes sign every other number. And so that's going to make it not quite so big. So the sum of the first 6 terms is 6561 times 1 minus negative 3 to the 6th power, all over 1 minus negative 3. So 1 minus negative 3 to the 6th power times 6561. Execute. Divided by 4. I screwed up on my parentheses here. And I get negative 1194102. Still a pretty darn big number. That's only 6 digits out. That's only 6 numbers in the series. And that already comes out to negative 1 million. It's only adding 6 numbers together. The geometric numbers, they can grow big very quickly. That's their design. And if you already start out big with 6561, it's going to get really big in a hurry. Times 3 times 3 times 3 times 3 times 3. Even though it changes sign every other number, it's still going to get big in a hurry. Okay? If you have not done so, please finish up. Here. Okay, so R on this one is 6 divided by 9, or 2/3. So the sum of the first 8 is 9 times 1 minus 2/3. minus 2 thirds to the 8th power all over 1 minus 2 thirds. 1 minus 9. Divided by negative 1 third. And I end up getting negative 6305 over 243. This one, I have a decimal, so decimals are just fine on this one. R is negative 125 over 250, or negative 0.5. So the sum of the first 5 terms is 250 times 1 minus negative 0.5 to the 5th power all over 1 minus negative 0.5. God, I can't write some days. 1 minus parentheses negative 0.5 in parentheses to the 5th power times 250 divided by 1.5, and I get 171.875. Not close? What? This one, n is 6, r is 2, a sub 1 is 3 times 2 to the first power, or 6. Okay. So I end up getting the sum of the first 6 terms is 6 times 1 minus 2 to the 6th power over 1 minus 2. And you get 378. This one, R is 3, N is 5, A sub 1 is 3 to the 1 minus 1, or 1. Right? Because 1 minus 1 is 0, 3 to the 0 power is 1. Anything to the 0 power is 1, except for 0. So the sum of the first 5 terms is 1 times 1 minus 3 to the 5th power over 1 minus 3. Minus 3 fifths divided by negative 2. And I get 121. Questions? Like I said, plugging them in the calculator, that's the most difficult thing. Okay. So these ones put in summation notation. We need to know 3 things for summation notation. We need to know the first term, we need to know R, and we need to know N. We need to know the N for the top of the sigma. This N does not change. This one's actually easier. Well, I wouldn't say easier than what we were doing the other day. But the formula part is first term R to the N minus 1, but you also have to figure out what N is. That's on these ones, that's the hard part. We have to solve for N. We've done this before. Okay. What we do is we use this formula that we got for the terms and go from there. So R is 1/2. Because what are we doing? We're going down by 1/2 each time, right? 8, half of 8 is 4, half of 4 is 2, half of 2, that would be 1, and then 1/2, and so on. So I have 1 over 128 is equal to 8 times 1/2 to the n minus 1 power. This is what we were doing the other day. This is probably the most difficult thing we're doing here, is trying to find n, particularly when you got goofy fractions in there. So 1/128 divided by 8 is 1 over 124.
How did you do it?
I divided both sides by 8. I typed in this as a fraction. So I get 1 over 1024 is equal to 1/2 to some power. So what I want to do is write 1 over 124 as 1/2 to some power. That's the easy thing I want to do. And it's not nearly as hard as it looks, because 1 to any power is out. I've just got to figure out what power of 2 is giving me 1024. So I'm going to start with 2 to the 6 and see what I get. Nope, 2 to the 6 is only 64. It's larger than that. So let's go 2 to the 8th power. 2 to the 8th, and I try it, and I get 256. 2 to the 10th power. Woo, there we go. Only took me 3 tries to figure out what it is. Literally, I took 2 to several powers till I got 1024. So this is to the 10th power. And I just tried. Use the calculator. Guess and check. Legitimate problem-solving strategy. Guess and check. Not always the best, but it works here. Okay. So 10 equals n minus 1. So n equals 11. That is the hard part of this problem. That is the hard part of this problem. Now I have to write it in notation. I need 3 things. I need this, I need this, I need this. So this is the sum from n equals 1 to 11, the number we found, times a sub 1, because that's what the formula is, right? 1 to n, whatever n is. A sub 1, r to the n minus 1. A sub 1, r is 1/2 to the n minus 1 power.
Oh, you leave it like that?
And that's it. You can't really do anything else. You don't want to do anything else. You don't. You don't want to do anything else. There are ways of simplifying it down. Don't, because it's hard. Trust me. You don't want to screw around with it. Leave it like it is. Okay? The other one we could simplify because it was easy to simplify. This one's a pain in the butt to simplify, and it doesn't really get any simpler than this. Really, it doesn't make that much of a difference, so it's not worth it. If it was something that made a big difference, yeah, it might be worth it. Okay. So we've done a few of these fractions. I want to do this decimal one next. So this is all decimals. This one's a little bit more difficult than the other ones. We haven't done a lot of decimals figuring out what n is. So I do need to figure out r. R is 70 divided by 50. I have a decimal in there, so I'm just going to do 70 divided by 50, and you get 1.4. Okay. This is where it's, like I said, solving for r is the hard part on this. We've done with fractions. Fractions, I actually think the fractions are easier than the ones with the decimals, personally. I know, I say fractions and half your eyes roll back. And the other half of you faint and fall on the floor. Not exactly, but.
Well, I'm fine.
So I have 268.912 equals 50 times 1.4 to the n minus 1 power. And I need to solve for n. Yeah, divide both sides by 50. And it's in decimal form. So 268.912 divided by 50. I felt that one coming. 5.37824. Do not round your decimals. Carry everything. Don't round it, because otherwise you won't be able to do the next part. Now, there are two ways to do this. Because I'm extremely comfortable with it, I would use logarithms. How many of you want to use logarithms? Let it be known for the tape that nobody's hand went up.
I already forgot.
Okay, it's all right. It's the same idea. I want to figure out 1.4 to what power equals 1.4 to the n minus 1. And that's really what you have to do, is you have to take 1.4 to powers until you match 5. 5 point blah, 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 blah. So I'm going to take 1.4 to the, I'm going to start with the 10th power just because. No, that's way too big. 1.4 to the 5th power, do half of that. And that's it. That's it. 5th power.
You did not.
I got lucky. I got lucky on the second try. And that's really, it's dead honest luck that I got on the second try. I tried 10. 10 was too big, so I plugged in 5.
So n equals
5 works. So 5 equals n minus 1, so n equals 6. I need this. I need this. I need this. So I have the sum from n equals 1 to 6 of the first term, 50, times 1.4 to the n minus 1 power. That's my answer. The hard part on this problem is solving for r. That's it. That's the hard part. Okay? And guess and check is what I use. It's legitimate. Okay? Questions? Do those two. You don't have fractions involved, so don't get too worked up. Okay, so in this one, r is -2. It's not too bad that way. So, but I need to find n. I have the first term, I have r, I need to find n. So I take 1536 is equal to -3 times -2 to the n minus 1. First thing, divide both sides by -3. So I get -512 is equal to -2 to the n minus 1. 512 is 2 to the 9th power. So this is -2 to the 9th is equal to -2 to the n minus 1. So n equals 10. So putting it in summation notation, the sum of the first 10, n equals 1 to 10, of -3 times -2 to the n minus 1. Easy peasy. On this one, not too bad, same idea. I have a sub 1 is this, r is 0.8, no, 0.2. So 2 divided by 10 is 0.2. So r equals 0.2, and decimals are fine. So I have 0.0032, got to get the decimals right, equals 10 times 0.2 to the n minus 1, divide by 10, which is 0.00032, equals 0.2 to the n minus 1, which is 0.2 to the 5th power. 0.2 to the 5th. Yep. Equals 0.2 to the n minus 1. So n equals 6. So I have the sum from n equals 1 to 6 of 10 times 0.2 to the n minus 1.
Are we trying to have it as 1/5?
Yeah, if you want to, but I've got decimals in there. Might as well do decimals.
Oh, when I did the 2 divided by 10, I just did.
That's fine. Oh, that's okay. I'm okay with that. And I do believe the next is independent work. You. Okay.